Let's make things better. That could be the motto of this channel, right guys? Welcome back to the Off-Grid Garage here in wonderful and beautiful sunny Australia. We're expecting another 32 or something today. So I'm running the chargers in limited mode. We are still charging the MB56 battery. What do we have outside? 92 amps outside, 5.4 kilowatt, limited coming from solar. And you can see the frequency is already shifted to 51 hertz to limit the power input coming from solar. We would be charging with over 10 kilowatt now, unlimited, but we're already at 97%, so that's all good. Yeah, guys, let's make things better, as it says here on the Wincon. That is a solar charge controller. I'll show you in a second here. We want to finally do it. We want to build a lithium-ion battery, yeah, out of used 18650 cells. And this battery here is a bit of an emergency build I need to do in the next 2 days or so until the new electric fence system comes for the paddock over there where our ponies are, because they are keen to get out now. We have very little grass on this paddock there, and they are very keen to get out into other paddocks now where more grass is, and they are not afraid anymore of the electric fence which is in place at the moment there. This is a very cheap, nasty eBay knockoff fencing system there. So it basically comes with a 4 or 5 ampere hour lithium battery, 2 little small solar panels, and yeah, the Energizer itself. But for some reason now, after 3-4 years, it's not as strong anymore. I can get a good spark where the cable comes out of the Energizer, but if I have a little bit of fence in between or something, the spark is very, very minimal. Probably the ponies, because they still have their winter fur, can't feel it. They just go through the fence as if nothing ever happens. So they don't obviously get a shock anymore, and the fence is constantly destroyed. So I ordered a much stronger one now, which is a bit, I think it's one for 60 kilometers of fence or something, and we've got close to 2 kilometers of fencing up there. But we need a 12-volt power supply. They usually talk about car batteries and everything, lead acid batteries, but this is obviously nothing we do anymore. You know, we go lithium. Yeah, I've got all these lithium-ion batteries here, which I would like to use for this project. And I probably go with a 3S battery, which will give us around 12 volts when the battery is fully charged, and around 9.5, 10 volts when the battery is empty then. So this should be fine for this Energizer, because if we go 4S, we will get up to 16 volts, which could be too much for the Energizer. And I would need a voltage regulator in between again to supply power to the new Energizer from a 16 volt battery. So we try 3S first and see how this goes. And I've sorted all these lithium cells here as per capacity. I've tested them all quite a while back. So 2.5 ampere hours, 2.4, 2.1. These are 2, 1.9, 1.6, 1.5, 1.4, 1.3, 1 ampere hour, and these were all under 1 ampere hour. So I'm not using these. I'll probably dispose all these ones here. They're all from used laptop batteries, as you can see, nice and colorful. I've got 11 2.2, 2.1 ampere hour batteries here, and we need 12. Right? I want to put 4 of these in parallel into one of these holders here. So we've got 2, 4, 6, 8 ampere hours per cell, and then 3 of these holders in series to make this 12 volt battery. I was going to use this 4S 40 amp BMS. Yeah, this is just a small PCB here, but I'm not going to use this one. We are going to use a JK-BMS, a BD48S. What it says here, this BMS here, it's the smallest JK-B series BMS you can actually buy, because it has nice settings, and I can also use a iBMS monitor board to hook it up to Wi-Fi, and I can monitor the battery in Home Assistant from far back in the backyard there, all the way here in the house, and I've got all the information done in Home Assistant, can check on the battery levels and everything and see if this all works out correctly. Yeah, so we're not going to use this one this time. I bought this here a long time ago. We will use it at some stage, I don't know yet. So this is the charge controller. It looks terrible. Look at this plastic. I've got this one here probably also for 5 years or so, not really being used much. This is the gray plastic as it was before, and this is how it turns when it sits in the sun for a while. It was just sitting here on the workbench, I think up here somewhere, connected to a small solar panel, and I charged my mobile phone from it from time to time. And it got the sun here through the window, and all the plastic turned yellowish, beige, terrible. It should be gray like this. Oh wow. Anyway, I think we've got the stats. No, we don't. So here you can have a quick look at the technical parameters of this solar charge controllers. Obviously it's a PWM controller. I have the SL03 30 amp version here. Crazy. So maximum voltage of solar panel 50, smaller than 50 volts. That's perfect. We have only 23 volts or something. Can do 12 volt or 24 volt batteries. And the most important stuff is that the stop charging voltage and flow charging voltage can be set between 9 and 35 volts. Look at this. So we can optimally and accurately set the stop parameters for our lithium ion battery here. Yeah, all the other parameters can be set as well. We've got a standby current of smaller than 15 milliamps. I need to factor this in as well in the capacity of this battery. We've got a low voltage disconnect and reconnect. Perfect. So this is all what matters, and we can set the solar charge controller depending on our needs. Perfect. So, and I definitely want to use a solar charge controller here because this is lithium ion, so it's not very happy when it gets overcharged. People in the comments and per email asking me a lot if you really need a solar charge controller when you hook up a small solar panel to a small battery, yeah? Because you've got the BMS in between with an active balancer, so it does all the balancing while you charge, and it also takes care if one of the cells goes out of spec, it disconnects your solar panel, yeah? So you technically don't need a charger as such. So here with the lithium ion batteries charging to 4.2 volts, we could set the over voltage protection to 4 volts, and it would charge the cells only to 4 volts and then disconnect the solar panel. So it would theoretically work as a charge controller as such, but obviously there's no second layer of safety then. And the BMS is clearly not designed to charge your batteries. That's what the charger is for, hence the name. But as I always say, the BMS is a safety device. Yeah, it is not there to charge your batteries. It is only monitoring your batteries. And if something goes wrong, it disconnects the battery from the charger and from your load. So you always want a charging device as well. And the charger regulates the current and the voltage going into these cells. Yeah, this one is charging, the BMS is protecting. And only if the charger fails, the BMS will kick in and then as a second safety layer disconnects your battery. If you wouldn't have this one here and connect your solar panel directly to the batteries, which will work, the BMS would constantly connect, disconnect, connect, disconnect, depending on the state of charge of the battery and the solar coming in and your load. But you have no second layer of safety. Yeah? If the BMS fails for whatever reason, there's nothing else protecting your batteries being charged from a 22 or 26 volt solar panel all the way up to 22 or 26 volts. And they don't like this. Yeah. And I don't want to have a bushfire over there in the backyard somewhere. So you definitely always want a BMS for your battery as a safety device and a charger which charges and controls your charging. Yeah. If the charger fails, BMS will protect, yeah? So it's super unlikely that we have both failing at the same time. It's like in your house, you've got a circuit breaker for your circuit and you've got a light switch, yeah? You use the light switch to turn on the light on and off. This is what the solar charge controller does, yeah? It starts and stops charging your battery. And then you've got the circuit breaker which monitors and protects your whole circuit. This is what the BMS does. BMS is the safety device, circuit breaker. This one controls charging, light switch. All right, and I also want to use these 5 amp little glass fuses here, which we have used before to protect the battery shelf. Each of the balance cables has one of these little fuses in between the BMS and the cell. So we want to use these ones here to protect every single cell in this pack with a fuse. So if something goes wrong with one cell and all the other cells would dump the energy into this one cell, 5 amps maximum, and then it disconnects this faulty cell. This is another layer of safety we want to build in. So we've got fuse, BMS, solar charge controller. And we'll also have another fuse then from the main battery, from the 12-volt battery to the solar fence energizer then. There could be just a normal 12-volt car fuse then, like 10, 20 amps or something. I think the Energizer only draws 180 milliamps or something, but it will be on 24/7. So it uses around 4.2, what it says here, 4.2 ampere hours or something in 24 hours. So if we have here a 8 ampere hour battery, it will run the fence for 2 days without a single drop of solar. So this should work pretty well. So first of all, we need to source the battery. So I want to go with these 11, and I probably use this one here. This is a 2082 milliampere hour battery, tested. So you probably use these 11 plus this one here and make them as uniform as possible. Yeah. So here's a 2022. These are all 2200s. And I give them the smaller 2000 in parallel. And then we have 4 here and another 4 here. First cell, second cell, third cell. Should be fine. And we want to put all these components here into this beautiful case here, right? It's a plastic case. I think it's from, oh yeah, here it says it. Super cheap auto here in Australia. Plastic ammunition style case. Heavy duty, blah, blah, whatever. It has this latch here at the side. Nice handle at the top. It opens like this, and this is where I want to put the batteries, the solar charge controller, the BMS in, all the cabling. We have to drill some holes here for the connections to the solar panel, energizer, and also an on-off switch. My first serious lithium-ion project. Here it comes. All right, let's get started. First of all, I want to check the voltages of all these cells here before I put them in parallel and prepare these holders here. Need to find another 2 of these. So we've got our 3 cells and can make a 12-volt battery out of it. Because I tested and charged them here quite a while back, they should keep the voltage if one of these cells here is below, say, 3 volts or something. Probably I won't use this cell anymore. It may have a fault, and replace it with another cell. I've got heaps of them here to choose from. Okay, I have made good progress in the last couple of seconds, as you have seen. So I've connected all the fuses now to one of the terminals here of this holder and connected them all together to a common, like, bus bar, I would call it. So this is our positive and negative. They need to be connected as well. And then we can already insert all the cells. So I have now connected all these 3 cells here in series. So on the left here, we've got our main negative. The positive of this cell is over here, goes with this cable to the negative of cell number 2. Positive cell number 2 goes with this cable to negative cell number 3. And cell number 3, this is our main positive of the whole battery, 12 volt. I've also used the cables of the glass fuses as the main bus bar underneath this battery holder, because the current will be very, very small here going into these batteries. As I said, it's 180 milliamps to the Energizer, and from the solar panel there will be a maximum under best circumstances of 2 amps coming into this battery. But we won't get these 2 amps because we don't have an MPPT. We only have a PWM charge controller. So there's no maximum power point. This one connects the solar panel as is to the battery and turns it off again when we reach the charge voltage. So in the second step, I've also connected the balance cables already here. Main negative goes over here, cell number 1, cell number 2, cell number 3, and the main positive for the BMS. Yeah, and this is the BMS we want to use, is the BD4A8S4P. So it's a 0.4 amp active balancer, maximum current 40 amps, far oversized, but this is the smallest JK you can get. And it can handle battery strings from 4S to 8S. It can also handle batteries from 3S if it is lithium ion. I've already checked the connector here for voltage consistency. That is all good. So let's connect the BMS negative with the battery negative. And then we can plug in the balance cables. Oh yeah, I haven't shown you. I've also connected the battery cells already. Not all of them, because some of them were a bit low in voltage. I don't want to connect 3 4-volt batteries with one which has only 3.5 volts. So all these batteries here, they are pre-charging now. 3.9 perfect, 3.87, 3.7, this one needs a bit, and 3.99. So I already can take this one out. This has 4 volts now. So this is good to go. And this completes, I don't want to put it the wrong way into this holder here, because this will be really bad. So okay, all 4 batteries are connected. So we can see here the capacities as well of all the cells connected. Okay, connect the positive to the BMS. And the switch, we need to put the switch in somewhere. Where is it? Down here. Let's turn it on and see if it works. Okay, let's measure some voltages here. So this is the main negative. Cell number 1, 4 volts. Cell number 2, including 8 volts. And cell number 3, we've got 12 volts. Perfect. I already checked the consistency of the balance cables, but I'm not sure why. I know why. Because the black cable is not negative. This is P negative. B negative is over here. So we need to connect this over here, of course. The blue one, black and blue. So now it should work. Beautiful. Okay, let's check which BMS that is. Here, second last one, BD4AS4P. Yes, it connects. Wonderful. Click to view alarm. What do we have? Cell count is not in. Password needs to be changed. Okay. Okay, let's change this one to 3. And click on lithium ion up here. We change the profile to lithium ion. Okay. Battery capacity should be around 8 ampere hours, probably 8.6. Oh, we cannot use any decimals here. Okay. BMS needs calibration after the relearning. Yep, that's fine. Okay, balance start voltage 3 volt. We can actually balance all the time with lithium ion, right? We don't have to wait to reach a certain voltage. We can just balance. Cell OVP 4.2. State of charge 100, 4.18. Okay, I need to modify this. 2.9. So obviously we are discharging the battery down to 2.8 volts. Okay, I have to go through all the parameters here. I have to think about what I want to set for lithium ion here. Yeah, we can see the balancer is already working with 0.4 amps. Okay, change the password so it doesn't nag us all the time with the password change alarm notification. Only 3 cells connected for an 8S BMS. That is cool. I'm not sure how far I should charge this battery here. Should I charge it to 4 volt only or 4.1 volts? What is a good and safe charge voltage for used lithium ion batteries? I'm definitely not charging them to 4.2 volts. Definitely not. So 4.1 will be the absolute maximum, I guess. I think 4 volt would be fine. Leave your comments down below if you have any suggestions how far I should charge this battery. Well, that works extremely well here. Nice. So I also thought about how to connect this all back to this box here. It would be nice to have this switch somewhere, and we can just toggle the battery with this switch here, but this one is obviously not waterproof, yeah? So when I put it somewhere here, it's not great maybe. We also need an XT60 connector or something somewhere where we can connect the Energizer and the solar panel, but this is all not waterproof then. So I'm not sure how to deal with all this yet. This is bastard plastic. It's really hard to drill or to file or to cut. It's like this soft material PE or something. Okay, let's see if the switch fits. It does. So I had a look on AliExpress, and of course there are waterproof switches like these available. The same as the XT60. I think they are called EW, XT60 EW. They come with a little rubber seal. So this is what I have ordered already. So a switch and 2 of these XT60 EW connectors. But for now, this is all I have, so we go with this stuff, and we have to somehow cover it until this other stuff from AliExpress arrives here. Also a bit strange what kind of nuts they have used here in these XT60 connectors. It is not M3 and it is not M2. It must be something in between M2.5 if this exists. Here on the photo you can see on the left, this is an M2 nut, and these three I have pushed out of the XT60 connector, so they are slightly bigger, and M2 obviously is too small and M3 is too big. So I'm not sure what kind of stuff that is, but they can be easily replaced with M2 nuts. So in the next step I have now created this sandwich battery here with some insulation foam in between these battery holders, and I've connected the negative and positive via a fuse holder. This is just a normal car fuse we will put in then to connect the whole battery pack basically, and at the end is an XT60 female connector top layer, and we can push this one into the box then. And here I have also connected XT60 female panel mount XT60 connectors to the solar charge controller here. One for the load and the other one for the solar panel. The battery is directly connected through the BMS. Here we've got the positive going to the solar charge controller, going directly to the XT60, and the negative obviously has the BMS in between. So, and the BMS then plugs into the battery. Okay, balance cables in. This one here. And now we should also see hello? I've just shown you the fuse for the battery. And this should turn on the solar charge controller. Okay, connect it. Yep, solar charge controller turns on straight away. Noise one. So just tapping the set button shows you all the parameters which are currently happening in the solar charge controller, your battery, or from the solar panel. But holding it down for a few seconds, it goes into the programming parameter list. Yeah, this is all explained here in the manual as well. So this is the important one, the charge voltage. Yeah, so 12.3 would mean 4.1 volts per cell if they're all balanced, and it should be balanced. Yeah, so we're charging to 4.1 volts, and after a while it goes down to float voltage, which is 12 volts. So it keeps the battery then on 12 volts for the rest of the day until the sun goes down, and 12 volts would be 4 volts per cell. And then there's also the disconnect, the low voltage protection recovery, basically 12 volt, and the low voltage protection at 9 volts, which is 3 volt per cell. So I may have to change these settings here a little bit, but I don't know yet. So that is good for now. Let's try this out first. Yeah, so obviously this solar charge controller is especially designed for lead acid batteries here. So it doesn't really do any absorption time or something. So it's not really suitable for lithium iron phosphate. But lithium ion should be totally fine because we don't need to absorb that long. And I don't want to fully charge these batteries anyway. So 4.1 volt it is, and then it drops down to 4 volt per cell. Should be fine, but leave your comments down below. I haven't used any heat shrink here on these connectors because we need to replace them anyway with the waterproof type of XT60. So I need to unsolder these ones anyway. Alright, let's drop this all into the box and see if it fits and if everything makes sense. Before we do that, let's connect the power supply here with around 15 volt to the solar input, which is, and this should actually start charging. I can see the animation popping up here on the screen already, and we can see 300 milliamps going to the battery on the BMS. Beautiful, that works. Okay, we've got 55 millivolt deviation at the moment. The balancer is already on because we are over, what did we set, 3.8 or something? Yeah, 3.8 volts. And then the balancer kicks in with 0.3 amps. Should be fine, right? All right, my friends, everything is inside the box. Look at this. We've got the solar charge controller down there, the BMS over there, our 3 battery cells, the main fuse, and I've also made a bit of a cutout here for the iBMS monitor board, which we will connect to this BMS in a later stage. But for now, the battery is fine as it is. Let's turn it on. Beautiful. There it is. 12 volt, 8 ampere hour battery. Nice. The electric fence Energizer has arrived, and I told you something about 180 milliamps, right? This one has actually 260. I think I went for a different model then. So I still had the 180 milliamps in mind, but now it seems to have 260 milliamps. We may have to upgrade this battery very soon, because this will last only one day without sunshine. But hey, there's no lack of sunshine down here, right? So let's give it a go and see if it works. So this Energizer comes with the crocodile clamps for lead acid car batteries. I need to replace these ones with an XT60 connector. And I think there's my warranty already gone. Alright, connected 13 volt power supply to these two cables here. Let's turn it on and see. Ooh, I can hear a tick. And the LED is flashing. 5. Power min. Oh, can I turn this up here? Ooh, I didn't know that. Yeah, set it to maximum power. Yes. Beautiful. And now we are touching. Okay, let's see what's going on here. 600. Wow, I can see 600 milliamps peak. And then it goes down to basically nothing. 13 milliamps. 600 to 13. So average must be 250, right? Don't think the device is actually very happy with low voltages. We are at 9.5 volts now, and this is the maximum I can get out of it. So it takes like 3-4 seconds until the next pulse is coming, and it only goes to 20. If I increase the voltage again to say 13 volts, we've got full power. And if I go too high, 15.6, it stops working as well. Then I lower the voltage and it starts working again. And we have only a very small window of operation here. This is not a quick win, guys. A nice, beautiful lithium iron phosphate battery would be the better choice for this device, because it keeps the voltage relatively constant. Here with the lithium ion we can see between 12 volt and 9 volts, we've got a fairly big span of voltage delta, but this is obviously not what the device is designed for. It's designed for lead acid batteries, which keep the voltage fairly constant as well. So neither a 3S nor a 4S is super ideal here. All right, fuse is in, everything is connected. Let's turn it on. No, let's close the lid. Turn it on. The Energizer is connected to the output now. Let's see if it turns on. Oh, it does! It does work! Full power. Yes, it does! Yay! It works! It works! But for how long? I don't know. We have to find out. Yeah, the solar panel. So I want to use one of these solar panels here. Come on, you son of a let me introduce you to the solar module. It's a TN40P 40 watt solar panel, 18.9 volts, 2.7 amps short current under optimal conditions. These panels are sitting here for the last 3 years or so. I use them during winter time to charge 12 volt batteries inside, and it takes like a freaking 4 weeks or so to charge a battery. So, but one of these modules here would be ideal to charge our solar fence battery, right? We just need to mount this somehow to the fence. Good morning, my friends, and welcome back. It is now the next day, and I was very busy this morning to get everything installed here in the backyard. So I prepared the solar cable. It's like a 17-18 meter run I have to do here from the solar panel down at the gate all the way up here to the corner where the Energizer and the battery sit. And I connected this long cable just along the fence line all the way down to the gate. So the solar panel actually sits in the sun and not in the shade here as it would be in the corner. There is a bit of sunshine coming through here sometimes, but down there a lot more sunshine, of course. And then I thought how to connect this battery box here at the fence. I didn't want to use the handle because over time this plastic may get a bit softer. It is already fairly squishy, you know, but over time with the heat and everything, the handle pulling on the weight of the battery may actually start bending the lid. And then we've got a gap underneath here where insects and ants can come in. So I thought about another solution where I can hang the box, yeah, and I came up with this metal wire hook situation now. So I bended these two wires here to hook into the fence up here, and down here we have a nice little cage now where the whole battery sits in, and I can just grab it like this and take it with me if I need to maintain it, repair it or upgrade it with an additional battery, and then put it back here in this little cage, right? And I use these what is it called? It's a polycarbonate material. It is a bit like the acrylic material we have used for the battery shelf. It's probably even the same, I don't know. But I had exactly these two pieces here in stock. Yeah, and I drilled some holes here at the top only. I put them here as covers on top of the battery as well as on the Energizer. So, I mean, the battery will be waterproof and so is the Energizer. But you know, protecting it from the sun makes a lot more sense. So they're not sitting in the heat here. In the afternoon there might be some sun coming directly in here. So it is a bit protected. I need to repair this fence first here, and then I can tighten these two roofs. I can just lift them up here and take out the battery. So this is all very maintenance friendly. The same up here, I can lift this one up, and this is only hooked in with a wire as well into the fence. And then later on it will connect here to the earth stake, which is my fence post, and also the electric fence then running far in the bushland over there. So this is the situation in the corner there where both the Energizer and the battery will live. And then we've got the cable running here. It's a 4mm double insulated UV resistant cable. I just mentioned this for the comments because people will comment and say, oh, you cannot use this cable. MC4 connectors because the cable was not long enough to extend it another 5 meters all the way here to the solar panel. Yeah, and the solar panel as well here hooks in with these wires here to the fence. And down here has another thick wire basically pushing it up a bit into the sun. Yeah, and I can even extend this one if I want to get a bit more sunlight. And there's also space for the second panel we had. Maybe in winter time one panel is not enough because the sun will come over this tree line here. We have to wait and see, right? Anyway, there's enough space for more panels here. All right, here comes the big moment now to plug everything in and see if it works, because I haven't done this yet. I have also installed the iBMS monitor board. It was working in the garage, but it connects to the house Wi-Fi, which is probably 150 meters this way. I can get it with a mobile phone, but the ESP32 Wi-Fi sits obviously in this plastic box here and is maybe not as strong. Well, we have to find out. So, okay, let's first of all, yeah, I could hear it beeping. Okay, recording. Well, there's only one BMS here in reach, so we couldn't connect to this. And we can see our 3 cells here. There's the JK inverter. No, this is the JK-BMS, 11.76 volts. Okay, let's plug in the solar panel. I have checked the polarity here, so that is all good. And solar goes in on the left. Temporary XT60 connectors until the ones come with the, oh, we can already see here 1.6 amps coming in. Oh, that's pretty nice. 1.66 amps. So that means with a 4P battery cell we have created, that's around 400 milliamps per cell, right? Per single cell we have. That is actually pretty cool. Let's see if we lift the solar panel up here, put it on a shallow angle directly to the sun. Yeah, we're getting 2 amps then. See, there's a bit more current coming, so I can actually optimize this by just using a longer wire here and bring it a little bit more up for summertime. 1.6 amps it is now on this angle. 8 divided by 1.6 5 hours. That's a charge time of 5 hours to fully charge the battery from 0, and it won't be 0 anyway. So we will see. We've got a second panel here on standby. Takes me probably 20 minutes to hook them both up again so we can double the current going into the battery. Okay, cool. So I have now connected to the iBMS electric fence monitor. This is this little board, this ESP board from our good old friend Peter. And we've got all the battery data here. I'm especially interested in the temperature sensors 1 and 2. That's 32 and 34 degrees already in this box here. But it is like 34 or something outside already. So that is room temperature basically, yeah, at the moment. There's our cell voltage 1, 2, 3, a little bit over 4 volts. And up here we can see the summary, 1.57 amps. 12.1 volts and 91% state of charge. We have no errors, uptime 3 minutes and 50 seconds so far. That is pretty cool. So if I disconnect this one, it should actually go to 0 after 10 seconds. There it is, 0, and now we plug it back in, and then we should see our PWM controller is charging again. 11.86 volts, voltage goes down obviously, and now we are back on 1.57 amps. That is pretty cool. So once we've got the Wi-Fi connected, we can have all these information from the BMS. It's pretty much everything, all the settings, everything. Even my password shows up here, yeah, 6x1. Everything will be in Home Assistant monitoring the battery inside this box here, especially the voltages and the temperatures. And you can send notifications then to your mobile phone if temperature gets too high. Or in a future upgrade, I want to also install a Sonoff switch in here, 12 volt, to turn off the Energizer via the mobile phone over Home Assistant then. So when we go in here, we don't need to go into the corner here all the time and turn off the Energizer. We can happily, easily do this here through the app in Home Assistant. And we can also check in the evening then if we have turned it back on again. Because sometimes we forget, and then you have little accidents like this happen here. And the ponies, obviously, they check from time to time if the fence is still on. And yeah, they need a reminder here and there that yes, the fence is the boundary. Okay, we've got the Energizer here with the XT60 connector as well. So we're plugging this one into here. Obviously, the fence is not connected at the moment, but I just turn it on. Yep, we can hear the tick, tick. Yep. Beautiful. This is all working nicely. So this Energizer is pretty much now running from solar directly. And we can see here in the BMS we have only 1.2 amps going into the battery. The rest is being used for the Energizer directly. So we are still charging the battery now, even the Energizer is running. Perfect. Just want to make sure I'm not touching these contacts down there when I turn it back off. And this should bring us back to close to 1.6 amps now. Yeah, it does. Balancer is already running because we are over 4 volts and we are charging to 4.1 per cell, so 12.3, right? So I need to check this from time to time here and see if it actually stops this little PWM controller. But well, man, knocked this off here within 1 day basically, with all the parts I had in the off-grid garage still, including the case and the batteries, and everything was just there. It just needed to be put together. So probably it takes you 2.5, 3 hours maximum to build such a battery here if you have all the parts. Maybe even 1.5, 2 hours only. Yeah, so this is actually pretty cool that this thing works now, this thing. All right, my friends, I think so far this video for today. Building a battery from nothing out of single lithium-ion batteries, which were in laptops before. And man, I learned a ton. All right, super interesting little small backyard project. No pain intended. We've got this all up and running, all working. So please let me know in the comments down below what settings would you set in the BMS as well in the Solar Charge Controller. How far should I charge these batteries? Should I float them? Should I don't think it's necessary to float, because you could just keep them on 4.1 volts all the time, fully charged basically, and then it should last overnight until the next morning when the sun comes out. And this may work now in summertime, but in wintertime we may need to upgrade these batteries to larger. We can put another holder with 4 additional batteries per cell in this battery box here. So I've got an 8P3S battery then. But we also need to find out if the Energizer actually works under 10 volts, I say, if it still outputs enough energy for the electric fan stand. So there's a bit of a test phase now coming as well. And of course, I'll let you know in a future video how this all goes here. And if we have to replace these batteries here with lithium iron phosphate maybe, because they have a more stable voltage here. It's maybe better for the for the Energizer. So let's find out. Let's see what's going on. As always, guys, thank you a ton for all your support, for watching these videos here, sharing, liking, becoming a channel member, donating to the channel, buying me a spat in these tropical hot conditions here in Australia. Thank you so very much for that. Thank you very much for all your nice and beautiful comments under these videos. Replying to all has become a full-time job now. So I'm reading all of them, but I may not be able to reply to all of you. But thank you very, very much for that. All right, guys, until the next video when we do... I think we do the MB56 capacity test next time, because it is now fully charged, finally, after a week, because I stupid set up the wrong parameters in the BMS, and it actually... Oh, well, I'll tell you later. And now, of course, the battery died on me. All right, just want to say goodbye. Stay charged, stay safe, and thanks again for watching. See you then. Bye-bye. Now there's only one thing missing. Can ponies even read? Maybe I have to explain it in a different way.